Hey guys, this is your speed, forces, and motion page of your ACP review. Let's get started. All right, here are 3 different formulas. I printed out a formula sheet because I forgot mine at school. If you look at your formula sheet, you notice there's only 2 formulas that really actually help us on the sheet. There's average speed, speed equals distance divided by time, and there's force, force equals mass times acceleration. Do you see a formula for acceleration here? No, they're trying to confuse you. Remember, if you have a formula that looks like this, if you know you're dividing or you're multiplying, you can always plug it into your pyramid and be awesome. I need you to remember when you get yours, write acceleration, and then it's A equals delta V over delta T. We'll go into this in just a second, but I want you to, when you get your period, you get your reference material, always write this formula because they don't give it to you. Okay, let's get started. You know, because you've been doing this for years, that speed or velocity are measured the same. The only difference is velocity has a direction and speed is just everything. But speed is distance divided by time. Okay. You know when you multiply things or when you divide things, if a D is on top, it's going to go up here for a pyramid. D does not make a difference where you put your T. And I put S and V. Miss Steele's a stickler. I always do this. I always draw my mathematical symbols so I know where I'm going. Going down is dividing, going across is multiplying. Okay. You know, if you want to find distance, cover up the D. T times S or V equals distance. T times S. Let's just say speed. Okay. Next one, I need to find time. Cover up T. D divided by S equals time. Okay, next formula. I just told you that acceleration is delta V divided by delta T. You need to know that delta is a Greek symbol and it means change. So I'm lazy. I always write acceleration like this. The long way to write acceleration is final velocity or end velocity minus initial velocity, start velocity, over final time minus initial time or start time. This is the exact same thing as this. This saves me space. I don't want to have to write this out all the time. So, knowing this formula, I know if you have the number on top, it has to go in here. Doesn't make a difference where I put my delta T. I'm just going to throw it in here. And I'm finding acceleration. Show me your symbols. Going down, dividing. Going across, multiplying. Cover and solve. Ooh, this is not a D. There is no D in this formula. That's supposed to be delta V. So, cover up delta V. You've got A times delta T. So, delta V equals acceleration times change in time. Okay. I need to find my delta T next. Cover up delta T. Delta T is change in velocity over A. So, it's delta V over A. Do not ever change the order of your variables if you're dividing. If it's on top, it always has to stay on top. Don't switch these two. They will always ask you questions where they switch them, or when they give you multiple choice answers, the answer is switched. Don't switch them. We're going to go over after this our first 3 problems, and I'll show you why they do that. All right, here is your last formula. Force equals mass times acceleration, m times a. You know m and a, if you set multiple, it's always going to go on the bottom. So you know mass acceleration go on the bottom. That makes a difference where you put them. And if you're solving for force, force has to go on top. Okay, so cover up m. Mass is force divided by acceleration. F divided by a. Acceleration is force divided by mass. Okay. Helpful hints down here. We measure distance. We are scientists. We have to use a metric system. We do it in kilometers, meters, centimeters, hectometers, decimeters, whatever. But our base unit is always meters. I don't know if you heard me say earlier, but we don't use the imperial system or the customary system, which we use in the United States, like feet, inches, yards, miles, because it's It doesn't translate. Nobody else in the world uses it besides us, except for Portugal. And also, it's a made-up system. I mean, the reason why we have feet were measured by King George's feet. His feet were 12 inches long, so henceforth we have a foot is 12 inches long. Force is always measured in newtons. Remember, the guy who found this, Sir Isaac Newton, had an apple drop on his head. He realized why gravity existed and figured out that the formula. So we always call force newtons. Time, we have so many different ways we can measure it. It can be in seconds, it can be hours, it can be minutes, it can be days, and so on. Speed and velocity is weird. We need to keep it in a measurement, so it's always going to be distance measurement per time measurement. Okay, so it's going to be like meters per second, kilometers per hour, kilometers per second. Okay, I want you to add down here acceleration. It's measured the same way. It's always going to be distance measurement by time measurement. So distance measurement by time per time measurement, but it's going to be squared. So in your 8th grade physics class, you might see variables with labels and not have them identified. You know, if you ever see a distance measurement per time measurement squared, it's always going to be acceleration. You know, if you're going to see newtons, it's going to be force. If you see hours, it's going to be time, and so on and so on and so on. Okay, so let's calculate our first 3 problems together. Okay, so 1. Deep Space One was a spacecraft powered by an engine that gave off xenon particles to change velocity. That was a pointless sentence that made no difference. It had a mass of 500 kilograms. Ooh, important words here. 500 kilograms, mass. Okay. Which expression can you use to find the spacecraft's acceleration? Ooh, we don't know acceleration. I'm circling it and putting a question mark. A question. If it created a net force of 0.10 newtons. We know newtons always equals force. So claim and identify your variables. We know M, we know F, we know we're looking for A. Okay, so M, mass is 500 kilograms. Force is 0.10 newtons. We don't know acceleration, but we know using our chart, we cover up acceleration. Oh, there it is there. Is force divided by mass. So acceleration is force divided by mass. I always do my algebra and plug it in. I say 0.10 Newton over 500 kilograms. Here is where they get you. You notice, right, by looking at these problems, our answer is A. Because that's what we did. We didn't even calculate it. All we do is set it up. We know C is stupid because they switched them. They're trying to trick us. Remember, Nito or Tybo. Top number always goes in the house, bottom number always goes out. So this number has to be on top because we know force is always on top. We know B is stupid because we're not multiplying. We know D is stupid because when do we ever add? Okay. Let's look at number 2. I don't know why there's not 2, put you there. Okay. 4 students push carts filled with sports equipment across the gym. Each student pushes with the same amount of force. Same force. Which cart has the greatest change in speed? Okay, well, I know my cubes. I know that I have to circle the 3 most important words. So I'm going to do greatest change and speed. Okay, so I know I'm looking for speed. The problem here is that I don't have a formula that would make sense for this because I got mass and I don't have a force. Okay, so think about this like this. Let's say we had a force of, I don't know, 10 newtons. Okay? So we know if we want to find our acceleration, we know force times mass, mass times acceleration equals force, or force divided by mass equals acceleration, right? With your chart, we want to find our acceleration, force divided by mass. Okay, so our made up mass is 10. Our made up force, because it's force or mass, our made up force is 10, our mass is 10. 10 divided by 10 is 1. You've got other masses here. Okay, so C, your force is 10, your mass is 20, 10 divided by 20, 10, 20, that should be 0.2. Let me double check my calculator. Okay, I'm back. Sorry, I actually ran through my camera's battery. So, I did my second one. I knew that force divided by mass is 0.5 on this one. Okay, my force over here, 10 divided by 1.15 is going to be, calculator again, because you're allowed to use your calculator. 10 divided by 15 equals 0.6. Just make that 0.7. Over here, 10 divided by 25. 10 divided by 25 is going to be 0.4. Okay. So, greatest change in speed. So, if I'm looking at masses, I know this one has the largest mass. But force divided by acceleration equals mass. We know speed and acceleration is like a change in speed, right? Because it's either speeding up or slowing down. So, looking at this information, we know my acceleration here is 0.4, my acceleration here would be 0.5, my acceleration here would be 0.7, my acceleration here would be 1. This would be my greatest change in acceleration. Okay, I know we looked for this in earlier and we said it was wrong, but we're looking for the smallest mass equals the greatest change. Okay, last one. So, a basketball with a mass of 0.6 kilograms, mass, accelerated with a force of 10.8 newtons. That's a force. If resisting forces are ignored, that means like if gravity is ignored, what is the acceleration of the basketball to the nearest meter per second squared? Okay, so we know mass is 0.60 kilograms. We know force is 10.8 newtons. We don't know A. Remember up here though, acceleration for us is force divided by mass. Force divided by mass is, force is 10.8 divided by 0.60. If I use my calculator, my answer is 18 what? Remember acceleration? Meters per second squared. All right, I have now gone through the first 3 questions of your calculating. Please take your time and redo your last 3, and thank you for watching.